Okay, next we are looking at the homework questions on the oxidation and reduction reactions known as the redox reactions. So there are some rules that relate to the oxidation and reduction. First of all, what is oxidation and what is reduction? So just let's do a quick review. Oxidation is obviously the addition of oxygen, right? And reduction is the removal of oxygen. Reduction also means addition of hydrogen, and oxygen means the addition of oxygen and removal of hydrogen. But at the same time, in terms of charges, losing electrons means oxidation is oxidation. But gaining electrons means gaining a negative charge is reduction. Increase in the oxidation number is oxidation, and decrease in the oxidation number is reduction. Also keep this in mind that the oxidation and the reduction, they go hand in hand. Substances that get oxidized act as a reducing agent, and substances that get reduced act as an oxidizing agent. Okay, so here we have shown you a scenario where oxidation is when you move on like in a number line, okay, when you move from -2 to -1. So that is oxidation, means you are basically losing an electron in that case. So moving from -2 charge, -3 charge, -4 charge, a negative charge to a less negative charge is oxidation. Oxidation is, moving from a negative charge to a 0 charge. That is oxidation also. Reduction, on the other hand, is moving from a 0 charge to a positive charge. Sorry, that is oxidation. Yeah, moving from a 0 charge to a positive charge is oxidation. Yes. And moving from a positive charge to another more positive charge is also oxidation. But on the opposite hand, moving from a more positive charge to a less positive charge is reduction. Moving from a positive charge to a 0 charge is reduction. Moving from a plus charge to a minus charge is reduction, or moving from a negative charge or 0 charge to a negative charge is reduction. Moving from a less negative charge to a more negative charge is reduction. So this is what it means. Okay. Now there are some rules regarding the oxidation numbers, and we talked about the oxidation numbers is basically the bookkeeping of the electrons. In other words, we are trying to find out what the electrons are doing. Where is that electron? What is it doing? Where, like when in a reaction, who started the reaction? Okay, so here we see the basic, these are all in your handout. So here the oxidation number of elements that are in the free state. This means that the electrons have not left the atom. They are still sticking with the atom in a neutral atom in a free state. So that is 0. The oxidation number in diatomic molecules such as Cl2, H2, O2, N2, Br2, I2, all these diatomic molecules is 0. When we talk about free state, we say like, okay, for example, copper, iron, silver, all these are like free state. So free state means uncombined state is 0. Then the oxidation number of diatomics is 0. We talked about that. Oxidation number of hydrogen is always +1, except when it is in metal hydride. Metal hydrides are like sodium hydride. Next is the oxidation number of oxygen. It's always -2, except the oxidation number of oxygen in a peroxide such as H2O2. In that case, it is -1. Then the oxidation number of all group 1A is +1, all group 2A is +2. For example, lithium, sodium, potassium, rubidium, it's always +1. Beryllium, magnesium, calcium, strontium, barium, radium, +2, group 2A. Okay. Then the oxidation number of, in general, the oxidation number of elements is equal to their charges. But in those situations where elements have more than one type of positive charge, like iron, like copper, like bismuth, like manganese, these have more than one type of positive charges. So in that case, you will have to do the calculations to get the oxidation number, or, that state. But for example, now look at the oxidation number of group 7A. Group 7A, it's always going to be -1, except when they are connected to a more electronegative atom, such as oxygen. So for example, here you have chlorine. Chlorine in HCl will always have -1 because hydrogen is less electronegative than chlorine. So in that case, chlorine will have a -1 charge. But when chlorine combines with a more electronegative atom, such as oxygen, so HOCl, HOCl means oxygen is more electronegative than chlorine. So in that case, when you do the calculations, you will see that oxygen has chlorine has a +1 charge. Okay, so that's the thing. Now, oxidation numbers tell us where the electrons are, who's giving the electrons, where, how the electrons are moving. Basically, it's that. Now, the sum total of the oxidation numbers of all the species in a polyatomic ion is equal to the charge. Like, for example, the oxidation number of carbon and carbonate and on oxygen in a carbonate, and then plus the 2 more charges. So the oxidation number of all of them combined together is coming out to be -2. So that is equal to the polyatomic ion. But in case of a neutral atom, the oxidation number of carbon plus the oxidation number of oxygen combined together is 0. So for a neutral atom, the sum total is 0, but for a polyatomic ion, it is equal to the charge. Okay, now let's look at these homework questions 19 and 21. So here they are saying identify which one is oxidation, which of this reaction is oxidation reaction, which one is a reduction reaction. So here, based on what we talked just now, we look at this here, sodium moving from plus to a 0 state, positive to a 0, moving back, it's adding an electron, gain of electron. So this is reduction. Okay, so this is a reduction scenario. On the other hand, so let's write this here, reduction because sodium is moving from +1 to sodium, a free state. And in a free state, the oxidation number is 0. So from positive to a 0, moving back, reduction. Nickel, the oxidation number in free state is 0, is moving to +2 state. So this is oxidation. So in oxidation, it is basically getting rid of an electron. So, but its oxidation number is moving from 0 to Ni+2. Okay, so anytime gaining an electron is involved, whenever there is a gain of electron, the gain of electron is reduction, but giving away of the electrons is giving away the electrons and moving from a 0 to a +2 charge. So giving 2 electrons or 1 electron or more is always oxidation. Okay, so that's one piece. Next is identify the reactant and the product, or tell whether which one is oxidized, which one reduced, and so forth. So here we are going to do this. Just give me 1 minute. Let me move this here. I need more space. All right, here. So now, in this case, let's write the oxidation numbers. So here we see the oxidation number of zinc. Zinc, the oxidation number is 0 because it's in a free state. Chlorine is a diatomic molecule. Diatomic Cl2, both of them, it's this oxidation number is 0. In this case, the oxidation number is equal to the charge. The charge on zinc is +2. So zinc has +2 charge. And chlorines, fine, there are 2 chlorides are being produced, but each has -1 charge. Chlorine will always have -1 charge when it combines with a metal. Okay, so this is the zinc chloride. Now, remember that crisscross. So how did I know zinc is +2? That 2 at the subscript of chlorine relates to the +2 charge on top of the zinc. Zinc, there is no number written there. That means it's 1. So 1 is coming from on top of chlorine. So crisscross. Anyway, now this is the +2 charge and chlorine is -1 charge. So if you look at it here, zinc is going from 0 to zinc +2 state, and chlorine is going from like 2 chlorine, so 0 Cl2 is 0 to 2 chloride ions -1 charge. Okay, so here this is reduction, this is acting, this is reduced, whereas zinc got oxidized. So moving from 0 to plus side is oxidation. So this got oxidized. But on the other hand, if it got oxidized, it's acting as a reducing agent. And here this is acting as an oxidizing agent. All right. So that's one piece. Now let's look at the next one. Iron. So there are two irons, but iron is moving from +3 state to I think it should be 1 minute. It should be iron. 1 minute. Okay, so that was iron +2. All right, so iron is going from +3 to +2 state. And tin is moving from +2 to +4 state. So going from +2 to +3 is reduction. Oh, sorry, from +3 to +2. 3 to 2 is reduction. So iron got reduced. Tin moving from +2 to +4 is oxidized. So this is oxidized. So you have to, like, here pay attention to this charge from 3 to 2 and 2 to 4. All right. Okay, so that finishes the questions till 21. Now we are going to look at the reactions, stoichiometry and the problems that relate to mole. So that is going to be in the next video. All right. Thank you.